What's going on, everybody? I'm Eric from Panola, and we want to go over just a couple of quick things in this video, as we do in all the other videos that we have on the channel. If you haven't already, go ahead and like and subscribe on the channel, and check out some of the other stuff that we have here as well. All right, so what's one of the biggest things that we deal with in networking that sometimes we don't even recognize? Binary. And that's where computers talk in ones and zeros, because at the root of everything, all data on the digital level will communicate in ones and zeros between the processor and across the wire. And it's not really recognized in a clear language that we understand. So in programming languages, they were developed to be able to help us take those ones and zeros and put them in a format that we understand a whole lot better, such as our native language. So from those programming languages, we have GUIs, or graphical user interfaces, and programs on the computer or any other system that we recognize more clearly and right away because it's in a language that we understand. But at the root of everything, there are still those ones and zeros. And oftentimes when we deal with networking, and more specifically subnetting, we see those ones and zeros more often, and sometimes it'll leave us a little perplexed at understanding how and why they matter so much when we deal with network address spaces. So in this little short video, we're going to take a look at understanding binary and get a quick understanding of how those ones and zeros add up to make standard numbers that we're more familiar with seeing in the decimal format. Now, when we say decimal format, we're talking about regular numbers, 1 through whatever infinity. But let's go ahead and break down binary and look at it from a very simple standpoint. Now, we're only looking at this from the networking aspect, and most systems talk on an 8-bit format to make 1 byte. And when we say bits, we're talking about each number that we see come up in a binary string. So oftentimes you'll see something like this on the screen where we have 00000000. All of those zeros make up 1 byte of data, and each individual zero in there is 1 bit. So 8 bits equal a byte. Well, how do we know which 0 or 1 in upcoming example means what? Well, binary is counted on a base 2 system. So if we're going from right to left, right being our smallest number in the binary byte that we see here, we have 2 to the power of 0. And then to the left of that, we have 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, 2 to the power of 6, and 2 to the power of 7. Now I'm going to put right below that what those actually equal up to, because a lot of times when we see stuff like 2 to the power of 7, it doesn't really make a lot of sense. But in this case, 2 to the power of 7 is 128. And so right from left, we have 1, 2, 4, 8, 16, 32, 64, 128. And those indicate what each bit of this binary string is going to equal out to. So in our example of the 8 zeros in our binary string right here, that's going to equal out to 0 because everything's turned off. Now you may hear these referred to as on and off flags, 0 being the off, 1 being the on. And it doesn't really matter how we refer to them. We just need to understand how to add these up and be able to translate these into a decimal number. Now I'm going to put on the screen here some examples. We're going to walk through these one by one. And the first one that we're taking a look at is in binary 00001001. And the way that we get the decimal number for this is by simply adding those ones, or the on flags, in this binary byte together. And the ones in this case are under the 2 to the power of 3, which is 8, and 2 to the power of 0, which is 1. So we just simply add 8 and 1 in this case, and it equals 9 in decimal. Now our next example is 00000111. And in this case, we're just adding 4, 2, and 1, and that equals a decimal of 7. And in our last example, we have 000110011, and I'm going to give you just a second to figure out on your own what this is, because we're just adding the 16, 2, and 1 together, and that gives us 19. And adding binary and figuring out what binary string that we have in that 1 byte to what decimal value it is just that simple. Being able to add all the numbers together would give us in decimal format what it exactly is. Now, where does this come into subnetting at? Well, subnetting will be in a future video that we have here to break it down pretty quick. But in subnetting, you'll see from left to right, zeros to ones, because you'll never see a 101. You'll see 0001111, and there won't be any mix and match. It'll be zeros on the left, ones on the right. And you could just simply add those up to be able to get the value of what that octet is supposed to be. And octet comes from the number 8 because we have 8 bits in a byte, and that's why in subnetting we refer to that one specific address space in IPv4 addresses as an octet. Now, I know that was pretty quick and to the point, but you'd be surprised at how many times we run across binary in the networking world, and we kind of get confused on how to add it up or where it goes from here. And where it goes from here is those 8 bits equal 1 byte, and out of that 1 byte, we get a decimal value that can be translated to other stuff like hex and also ASCII later on as well too, if we want to do that. But this was just to be able to go through and get a base understanding of how to add binary up and make an actual decimal number that we're more familiar with in our native language. So I hope you all appreciated this video. And if you like this video, go ahead and leave a like and a comment or share it with your friends. And also follow along at panola.edu, where we have other cybersecurity courses, networking, and digital forensics. It's never too late to figure out a new craft. And also if you want to expand on knowledge that you already have.